So you've got, you're going to go to the Eureka stuff?
Yeah, so Microsoft has been focused on trying to understand where the limits of these models are. And you probably heard of lots of AI benchmarks, and you hear, the latest version of O1 scores close to 100% on this benchmark or that benchmark. The problem with those benchmarks is that they're what's called saturated, meaning the models have gotten good enough to get close to 100%. And so they're not really meaningful anymore in measuring model quality. We really want benchmarks that are realistic, that are representing real kind of use cases for those AI models, where we can make them as hard as possible. Ideally, we can infinitely scale their difficulty so we know exactly where the boundaries of these models are. And so Microsoft has been working on a benchmark framework called Eureka. You can see the paper published here just a couple months ago, specifically designed for these kinds of beyond frontier model benchmarks. And with many of the benchmarks that are in it, like in those examples that Scott just mentioned, the different categories of reasoning that can be arbitrarily scaled so that we can see just where the limits are. So, for example, one of the kind of hype around long context, how many people have heard of long context, like million token context and 2 million token context? So a few of you have. So a lot of these AI model developers are bragging about how big the context of their models
Yeah, they're oversimplifying things, and they're saying, oh, well, that's not going to work. You don't have a big enough context window. This has 1 million. It's going to be way better when it has more context.
Yeah, and so just to be clear, what the million context window means is that you can shove tons of documents and books into that million token context window. It'll all fit. And presumably, then you can ask the model questions about that content or have it reason about that content. And one of the ways that a lot of these AI model developers show just how cool their context windows are is they'll say, we gave it the needle in the haystack test. And the needle in the haystack test is throw a bunch of crap in the context and then have the model go find something specific buried within it. One of the first examples of the needle in the haystack was somebody gave a model, when the context window got big enough, a full copy of the Great Gatsby book. But in the middle, they inserted one of the characters pulling out an iPhone. And then they gave it to the model and said, is there anything unusual about this text? And the model said, yeah. I found that somebody is using an iPhone. The book's set in the 1920s. It doesn't make any sense. So they said, look, this models know how to look at their long context and find information out of it. The problem is that models actually aren't that good at long context retrieval for anything real. And so that's one of the examples in this Eureka benchmark. If you go take a look, this is kind of cool, is this little interactive chart across those various tasks that Scott was mentioning, where it shows you how models perform across them.
So that diagram, if you think about this diagram, if you see like object recognition, if it's near the edge, that's saying it's really good. But if you say object detection and it's not near the edge of that outer part of the circle, it's not that good. A perfect model would have a perfect circle. And you can see that information fact retrieval precision, all the models are kind of mid. While something like toxicity detection, we actually do a decent job on many of the models, and it gets well out towards the edge. And to his point about it being infinitely scalable, if we reach that edge, we can continue to push the envelope of what a good or well-behaved or correct model is. But we can say really authoritatively that retrieving facts, these things are not awesome at.
Yeah, and long context. So here, I'm going to give you an example. This is a Jupyter notebook that I've got it loaded up to point at Azure OpenAI, GPT-4, and I'm giving it some context here. You can see these two paragraphs here, where it says John's living room starts with John's living room is marble floored, and then Ethan Washington is in John's living room. And then we're just going to ask it, where is Ethan Washington in a marble floored room? Answer only true or false. So when we give that context to GPT-4 and ask it, it says true, and that is correct. That's the ground truth. Now what we're going to do is give it the same information. Here, Ethan Washington's in John's living room, and way, way up here is the text that John's living room is marble floor. This is actually one of the samples from that Eureka benchmark on long context retrieval. And so you can see these two pieces of information required for it to answer that question are far apart in this longer context. And now when we give it that question, it says false when the answer is true. So there it just failed because we'd taken those two pieces of information required for it to answer spread them apart in this long context, and now it can't answer.
So how do we feel about that?
Not good.
Yeah.
But let me show you another example. This was long context retrieval. So people also expect in RAG situations where you give the model a bunch of content and it's from a RAG retrieval and you put it in its context and then ask it questions about it, that's going to be able to answer in a very high accurate way. So everybody kind of knows that if you just ask the model with no information in its context, that it's going to be pulling from its own internal knowledge, and it's less reliable than if you just put it, here are the answers right here, just give me some, answer some questions about it, that it's going to be much more accurate. Well, it turns out that as that Eureka benchmark chart showed, that they're also not great at that. Yes, they do well up to a certain point, but then they can start to fail. And so this is an example of that. This
is a frontier model. This meaning frontier again on the final frontier, at the edge of the frontier. This is the newest, greatest, fanciest thing.
And so this one, what we're going to do is give the model a bunch of books by a particular author. Now, then ask it a question. List all the books by Angel Flores, born in 1900, satisfying this. Book published between this date and this date. There's actually 2 books that were published between those dates in this text. And I'm not going to bother pulling them out because we're going to see them later here. But when we give that context to GPT-4o and ask it to go find those books that were published between those dates,
it's taking a minute.
It found one. And here's the one that it found. But the ground truth is that there were 2 of them. And sometimes, if you do this again, it'll say none, no books were found in that window. So this, again, is another example from that Eureka benchmark that shows you, hey, even for RAG cases, you need to be careful and assume that the model might miss information and not provide you the right answer.
Yep. It cannot be overstated. Trust but verify.
Yeah.
I think of a large language model as a really eager intern. And it's got a lot more energy than I have. It's got abilities to go and dig through a bunch of information. But when I get that information back, I need to go and verify that, hopefully with code.
Now, one last thing I want to show on this is a benchmark that I've come up with. And this also shows interesting behavior of these models. And that is this behavior right here, where in this particular benchmark that we're creating, it's logical reasoning over a set of relationships. So the idea is you give the model a set of logical relationships, greater than, less than, and then ask the model, given the set of relationships, are there any contradictions? Or are there any cycles where one thing is better than others, bigger than the first thing? And the model's goal is to go figure out, hey, are there any cycles or contradictions in this and answer? And so you can see this is GPT-4o processing this, and it's doing an analysis, and then it comes to this conclusion. The relationships are, these 2 relationships are in conflict because the blah, blah, blah is in conflict and blah, blah, blah. So it gave us one answer, but then watch this. I don't think so. Are you 100% sure? It's like, well, let me take a look at it again. And then it comes down, blah, blah, blah. Let me analyze it. Oh, final answer. There are no contradictions.
So which one is right?
Which one is right? I don't know. I bet you.
You're literally gaslighting GPT-4. You're just like, nah, I don't think so.
Actually,
try it again.
Have you heard the stories about AI models gaslighting people?
Really?
Yeah. So AI models can also gaslight people because they can be sure that they're right. And if you say, wait a minute, I think you're wrong, they'll be like, no, I'm absolutely right. Here's the reasons I'm right, when they're actually wrong. And
I do not want an AI model to say, trust me, bro. That is not, that is not a reference. That is not okay. So this idea of reasoning not being something that you can count on becomes a real problem because we are starting to look at these things as factual. People will screenshot stuff in arguments and say, look, it said so. This is not smarter than you. It thinks differently than you. It's reasoned differently than you. And it's not grounded often in reality. And the opposite of groundedness is
ungroundedness.
Yes. And ungroundedness is a kind of hallucination. Now, I don't typically like that term. I don't like to use the word hallucination, but that has become the word that people use.
And actually, I think the word that is more accurate is confabulation.
Ooh, that's good.
Yeah.
Confabulation.
Confabulation.
Yeah. I don't like hallucination because the model doesn't have mental health. But it can be a BS generator, and that can be problematic.